Okay, we are going to start a new topic today, and these are called polar coordinates, working with polar graphs and trig also. So polar coordinates or polar graphs, polar equations, use circles for their grids instead of the XY axis that we're used to. So these concentric circles that you're looking at is actually a polar graph right here. So the first thing we're going to talk about is the polar axis. That's this part right here. The polar axis is that guy right there. The polar axis is always on the positive x-axis. So the polar axis is on the positive x-axis. And then the next part of the polar coordinate is this part right here, and that's called the pole. Now, a lot of times people like to think of it as the origin. The origin is on the rectangular grid, which is the XY coordinate plane that we're used to. It's not technically the same thing, but a lot of people reverse them. They say like the origin and the pole are the same thing. If you think of a globe, at the very top of the globe, you'll think of like the North Pole or the South Pole. That would be where the pole would be. And then the circles that come off of that, the latitude or longitude circles, that's where the circles come from on this. So if you look at a globe, you'll see what I'm talking about. Okay, let's say, for example, I put a point on our coordinate plane here. Let's say I put it right there. I'm going to call it point P. The way that we talk about the location on here is kind of like an ordered pair. It's got a location, it's got a radius, like how far out do we have to go, and it's also got an angle, which we would call theta. So R is the radius. Now this is the directed distance from the pole to our point. Now the word directed is huge important here. It tells me which direction to go. Now the other thing that we need to know is theta. What angle do I need to go to? This is the directed angle. Again, that word directed's coming in there. Directed angle, whose initial side, remember that's the starting side, is on the polar axis, and the terminal side, that's the side that it ends on, is the side that connects the line to OP. So our pole, we usually call it point O. So the terminal side would be this part right there. So it connects the pole to our point. And then we write this as an ordered pair, r comma theta. That's how we write a polar point right there. Okay, so let's actually take a look at how to graph one of these guys. So here is what a polar coordinate grid actually looks like. It'll have the unit circle on it, but then the unit circle is just this guy right here. That's 1 unit away. So that tells us where all of the radians are that we know, and then it just keeps going out. So this would be a radius of 2. This is a radius of 3. So you can kind of see what's going on here. And we're wanting to plot the point 2 comma pi over 6. So when you get ready to do this, the way that I usually do this is I try to figure out where is my location first. So where is pi over 6? So I locate pi over 6, which is right here. And then my radius is positive. So I start at the pole and I count out 2. So I go out 1, 2. So right here is my point. That is our point for that location. Okay, let's go over to our next one here. Now we have negative 3 comma 7 pi over 6. Now this one's a little different because remember that word directed that I had us underlined just a second ago? Then our value is negative, so it switches directions. So we got to write this down here. So when r is negative, we have to kick our point into the opposite quad. Now, that's the same thing as saying we have to add pi to it. I like saying we kick it into the opposite quad. Okay, so it looks like this. We start by going to the location 7 pi over 6. So 7 pi over 6 is right here. Now, since r is a negative, instead of going 1, 2, 3 this direction, I kick it into the opposite quad. So I'm in quad 3, so I actually need to kick it into quad 1. So I'm going to go 1, 2, 3 into quad 1, and right there is the location. So when r is negative, we kick it into the opposite quad. Now, not only can r be negative, but theta can also be negative too. So theta can be negative and r can be negative. So we already know when theta is negative that we have to go clockwise. We've known this for a long time, no different there. All right, so here's our point right here on ours. So I want to come up with 4 different ways to talk about this exact same point. So we're going to start off easy. Let's make everything positive to begin with. So the first thing we want to do is to find out what our R value is. So we went out 1, 2, 3, 4. So our R value would be a positive 4. And then we want to figure out what angle we went to. So we went out to 5 pi over 3. So the first way that we can talk about this point would be 4 comma 5 pi over 3. All right, what if I wanted to keep R positive again? So let's say I still wanted to keep R positive. But this time, the way that I need to keep it positive then would be for me to have to go a different direction. So I still want R to be 4, but now I've got to figure out how can I get to this point using theta to be negative. Well, for theta to be negative, I have to go this direction. So I can't say 5 pi over 3 because that takes me the wrong way. So how do we go this direction? What do we call that? Well, you guys remember that. We're going clockwise, so that's the same thing as negative pi over 3. Okay, now let's go into where r is negative. So if r is negative, remember it's kicking me into the opposite quad. So when r is negative, let me switch colors here so we can keep track of it. So when r is negative, that means that I'm going to be in the opposite quad. So right now my answer's in quad 4. So I know I would have to be in quad 2 in order to be kicked into the opposite quad. So 4 out of opposite of 5 pi over 3. So opposite of 5 pi over 3, so if I just draw it straight across here, is 2 pi over 3. Okay, so let's convince ourselves that this is right. So if I went, I'm going to erase all this. So if I went to 2 pi over 3, so if this is my angle, 2 pi over 3, and I counted out 4, 1, 2, 3, 4. But wait a minute, 4 is negative. So I need to actually shoot it across here, 1, 2, 3, 4. That puts me right exactly where we need to be. All right, last one, we got to come up with this. We still want R to be negative. So how else can I get to 2 pi over 3 so that I can shoot it across over there and make it into the opposite quad? So now I got to think about how else can I get to this location? I've already gone counterclockwise to get to 2 pi over 3. So my only other option then is to go counterclockwise, or excuse me, clockwise. So what is the angle going clockwise? And of course, you guys know that as well. It's negative 4 pi over 3. So there's 4 ways that we can talk about this one point right there in polar. Now, if we merged a rectangular grid, which is the XY coordinate that we know, and then we put those circles from the polar grid on top of each other, it makes a pretty cool graph. It overlaps each other. But it's really easy to see how things would line up a little bit better. So if you think about, like here's my XY axis, and then I would have all of these circles in here. You can kind of get the idea of how it would look. Let's say that I had a point and I want to convert it here. So we're converting to polar from polar, so that would be like r theta, and we want to convert it back to rectangular, which is xy. How do I do that? Okay, so if we're thinking that I had some point in polar, so I had some point up here, it would have an r value here, and it would have a theta value here. Well, how do I find that in terms of x, y? Well, we know if we're changing it back to rectangular, we would just go across x and up y. So to get x and y, we go back to trig on this one. We would say that x is the same thing as r times cosine theta. So think about cosine theta. Cosine theta is adjacent over hypotenuse. And if I solve for x, I just multiply both sides by r, so x would be equal to r cosine theta. That's how we get that formula. Okay, how do I solve for y then? Well, to solve for y, then we would do sine theta is equal to y over r. And to solve for y, then we would just take r sine theta. That's how they're deriving our formulas right here. So y would equal to r sine theta. That's how you convert from polar to rectangular. All right, so let's check it out then. We've got the point 6 comma pi over 3. So using our formula, we know x is equal to r, which is 6, times cosine of theta, which is pi over 3. And then we just simplify if we can. We know pi over 3. That's one of them that we know. So the cosine value at pi over 3 is just a half. So this actually reduces down to 3. And then to find the y value, you do r sine theta. R is 6. The sine value at pi over 3, that's just square root of 3 over 2. And then when we multiply, we get 3 square roots of 3. So to turn this back into a rectangular point, our x value is 3, our y value is 3 square roots of 3. All right, let's try the next one. Our r value is 4, so we've got cosine of 5 pi over 4. And then I'm going to simplify that. The cosine value at 5 pi over 4 is a negative square root of 2 over 2. And when we reduce that down, we're going to get negative 2 square roots of 2. And then our sine theta is what our y value is. So 4 sine of 5 pi over 4. And again, the sine value of 5 pi over 4 is a negative square root of 2 over 2. So we're getting the same value on that one. So the rectangular answer for that would be negative 2 square roots of 2, comma, negative 2 square roots of 2. So that's how you take a polar and change it back into rectangular. Okay, now let's flip it around. Let's go from rectangular to polar. So we're going from x, y, and we're changing it to r theta. Okay, so kind of the same idea here. If we're in rectangular, we have our triangle x, y. Well, to find r, we would just do Pythagorean theorem. To find it, we do x squared plus y squared equals r squared. And then to find r, we would square root that. So that's how we would find r. And then to find theta, well, we would know the x and y values because that would be the ordered pair we would use. So y is opposite, x is adjacent, so that's just going to be tangent. So tan theta would be y over x. So to solve for theta, we would do tan inverse of this. Now, you guys remember, hopefully, dealing with inverse of tan, that lives in quads 1 and 4 exclusive. So we got to be super careful about what tangents we're in, or what quadrants we're in when we're dealing with tan inverse. All right, let's write our formulas down. So converting from rectangular to polar, the r formula is just going to be the Pythagorean theorem, square rooted. And then theta is going to be tan inverse of y over x. All right, let's check it out. Now, the first thing I like to do when I'm doing these, just because tan inverse throws people off, is I'd like to figure out what quad I'm in here. So negative 3, 5. So I'm just going to quickly sketch this one. Negative 3, 5 puts me in quad 2. So I'm going to make a little note to myself. I'm in quad 2. So negative 3 goes here, 5 goes here. I need to find the radius. So I'm just going to take each value and plug it into the Pythagorean. and simplify. Negative 3 squared is 9. 5 squared is 25. Add those guys together, we get 34. So the R value is the square root of 34. And then to get theta, we're going to do tan inverse of negative 5 over 3. Okay, grab your calculators. Make sure you are in radian mode and plug this in. Okay, so when you do second tan and then negative 5/3, you're getting theta to be about negative 1.0303, on and on. Okay, now we know tan inverse lives in quads 1 and 4 exclusive. So that negative radian puts me down here in quad 4, which is fine, except where was my point located? My point was located in quad 2, and this put me in quad 4. I don't want to be in quad 4. I need to be in quad 2. So the way that we move it up to quad 2 is I have to add pi to my answer. So go back to your calculator, take the decimal answer that you have right there, and add pi to it. So theta should be approximately 2.111. And that puts me in the correct quad. That would put me up here in quad 2, which is where I need to be. So then the way that we would write our answer here would be square root of 34, that's my R value, and then 2.111 would be theta. That is my rectangular coordinate. And then on the next problem, we've got 2, -6. So again, I'm just going to sketch this real quick to figure out where I'm at. So 2, -6 puts me in quad 4. So we're going to find 2, -6. Let's go find our R value. Again, just using Pythagorean theorem here. 2 squared is 4. -6 squared gives me 36. I get the square root of 40. And then break that down. Well, that goes to square root of 4, square root of 10. So we get 2 square roots of 10. And then to find theta, we're going to do tan inverse of y over x. So this turns into tan inverse of a -3. All right, so go ahead and plug that into your calculator. So we're going to do second tan of a -3. And I'm getting about a -1.249. Now again, we know tan inverse lives in 1 and 4, and a negative radian kicks me down there, which normally I would be all about like, hey, this is totally okay, we're good to go. But then I checked my directions. My directions on this problem restricted my domain. They're telling me I can't go negative radians. I cannot do that. So the only way I can get my answer here is if I go counterclockwise. So on this particular problem, since my domain has been restricted, I'm going to actually have to add 2 pi to this answer to get it into the proper domain. If this domain were not restricted, then -1.249 would be my answer. But because they restricted my domain, I'm going to have to add 2 pi to that. All right, so go to your calculators, add 2 pi. And your theta should end up being about 5.034. So our polar point would be 2 square root of 10, comma, 5.034. And that is how you change rectangular into polar. Okay, next up is graphing complex numbers. Now, we've graphed real numbers our entire life, but some of you probably have not graphed imaginaries. And it's actually pretty easy. Let's just recap complex numbers real quick here. A plus bi. A is the real part of our problem. B is the imaginary part. So A is the real part, B is the imaginary. So normally on an XY axis, this would be X, this would be Y up here. But when we're dealing with complex numbers, it's x and I. And it works exactly the same way as x and y did, except now it's x and I. It's real and imaginary. So that's what our axes are right there when you're getting ready to plot. So it makes it super easy to do these. Okay, so looking at our absolute value of a complex number, they use the letter z now to talk about these. So our formula z is equal to a plus bi. That's just talking about a complex number. And then the z value, the absolute value of z, is just our square root of our Pythagorean theorem. Now, sometimes some textbooks write it like x plus yi. Our book uses a plus bi, but I just want you to be aware some textbooks change that around, so don't be intimidated if you see it a different place. All right, let's graph this first one here. We've got 3 plus 4i. 3 is the real part, 4i is the imaginary part. I should use a lowercase I on that, sorry. So what we're going to do is we're going to go 3 to the right because it's positive, and then 4 up because it is positive. And right there is your complex number plotted on the complex number grid. All right, let's reverse it. Now they gave me a point, and I'm supposed to come up with the location of it. So the way that we write this is we always start with the real first. So on this particular one, starting at the origin, I have to go 1, 2, 3, 4 to the left. So I'm going to go -4. And then from there we go 1, 2, 3 in the imaginary. So -3i. And so they're going to call this z equals -4 minus 3i. That is the name of that point right there. And that's how you graph imaginaries. Pretty easy. Now let's take imaginaries into the polar world. So luckily, the formula from converting from rectangular to rectangular complex to polar is super easy because we're going to use the same formulas. So for r, it is still the square root of Pythagorean theorem. So it's still the square root of a squared plus, x squared plus y squared. Some textbooks would use the square root of a squared plus b squared. So again, just depends on what textbook you're using. And then theta is still tan inverse of y over x, or b over a, depending again what textbook you're using. I'm going to stick with x and y's because that's kind of what we're comfortable with, but just want you to be aware it could be a different format. Okay, let's look at our first problem here. It's a -3 plus I square root of 7. So let's check it out. First off, what quadrant does this put me in? Where is -3 plus I squared of 7? Well, -3 is the real number. So that's going to put me left, and I squared of 7 is positive. So I'm up here somewhere in quad 2. This is going to be placed somewhere in quad 2. All right, let's find our R value. So we're going to take the square root of our real piece, which is a -3, and then squaring that, and then squaring our imaginary piece. That is the square root of 7. Square root of 3 squared, of course, is 9. Square root of 7 squared is 7. Well, this turned out nice. You guys get 4 for R. Okay, do theta is equal to tan inverse of y over x. So we've got the square root of 7 over a -3. Go ahead and grab your calculators. We're going to do second tan square root of 7 divided by -3. Now, when I did this one, I got about a -0.723-ish. I rounded a little bit there. Now, we know tan inverse keeps me in quads 1 and 4, and so a -7 puts me down here, -0.7, excuse me, but I need to be up in quad 2. I don't need to be in quad 4, I need to be in quad 2. What do I need to do to kick it up into quad 2? Hopefully you guys said we need to add pi to this. All right, take your answer and add pi to it. Adding pi kicks me up into the opposite quad. So that would make it 2.419 roughly. Okay, now the way that you write the polar form on these is a little bit different. So you've got a couple different ways that you can write them. We can write 4 cosine 2.419 plus 4I sine 2.419. So that's one way you can write it. The other way that shows up quite a bit is they factor out the GCF, which is the 4. So you might see it written with the 4 out, and then this is just cosine 2.419 plus I sine of 2.419. So be prepared to see both of those ways. All right, let's pause the video and see if you guys can handle the next problem. 2 minus I. Figure out what quad you're in, and then see if you can come up with the answers. So go ahead and pause the video. Let's try it. Okay, we are in quad 4. Our real part is 2. Our imaginary part is a -1. So when you get ready to do R, we've got the square root of 2 squared plus a -1 squared. That gives me 4 plus 1. I'm just getting the square root of 5 for R on that one. And then to find theta, I'm going to do tan inverse of y over r. So it's y over x, -1/2. And when I plug that into my calculator, I'm getting a -0.463. Okay, tan inverse lives in 1 and 4, and we're getting a negative. Now, check the directions on this one. Oops, sorry. In the directions, they don't show any domain restrictions. On that problem on the front, it was restricting our domain, so we had to add 2 pi to it. It's not restricting it here. So I don't have to worry about adding 2 pi to it. And since tan inverse lives in quad 4, and my problem is in quad 4, I don't have to do anything extra on this one since there's no domain restrictions. Okay, so here we go. We're going to write it out. R cosine theta plus R sine theta. So we've got the square root of 5 cosine of a -0.463 plus I square root of 5 sine of a -0.463. And again, you might see that one where it is factored out. That square root of 5 might be factored out. Either answer is completely acceptable. That's what it looks like. All right, that's rectangular complex to polar form. Let's flip it around now. Let's go from polar complex to rectangular. So formulas exactly the same. So x is going to be r cosine theta. Y is equal to r sine theta. So this is nice that these formulas don't change. Now check out our first problem here. We have 3 cosine pi over 3 plus 3I sine pi over 3. I need to figure out what r is and theta is. Well, r shows up right there, so I know r is 3. And then theta is showing up right here, so I know theta is pi over 3. Once I know that, all I got to do is plug into my 2 formulas over here. So x is equal to r, which we know is 3, cosine theta, which we know is pi over 3. All right, go to pi over 3. What's the cosine value up there? Should be 1/2, so our answer should be 3/2. And then do y, r sine theta. And at pi over 3, our sine value is square root of 3 over 2. Now, there are a couple different ways that you might see this one written. You could see it written just like a plain old ordered pair. Don't forget to put the I in it, though. Or you might see it written, this is a common way that you would see it written, too. So either one of those is acceptable. All right, let's see if you guys can do this one. Go ahead and pause the video, figure out what R is, figure out what theta is, and then write your answer. Hopefully you figured out R was 4 and theta was 3 pi over 2. So we got x is equal to 4 cosine 3 pi over 2. Well, at the bottom of the circle, cosine is 0. So we should just get 0 for that one. And then for y, we get 4 sine of 3 pi over 2. And at the bottom of the circle, sine is a -1, so we should get -4 for that one. Okay, so as an ordered pair then, this would be 0, comma, -4i. Or you could write it 0 minus 4i, but since 0 is our real number, we don't necessarily need to write that. You would probably just be seeing it as -4i. All right, people, that is polar. Good luck on the homework today. You're going to be amazing.